And I think you'll agree that you now know a lot. So you know all of these problems here to be NP-complete, which you probably didn't know before taking this course. We've also investigated intelligent search trees for vertex cover and for click and independent set. We unfortunately were not able to find one for shortest tour, but we know one for 3SAT. We talked about pre-processing for vertex cover, and we talked about pre-processing for 3SAT. And we showed that vertex cover is fixed parameter tractable using the size of the solution. And we showed that shortest tour could be fixed parameter tractable as well as 3SAT using a measure known as distance from triviality. We also talked about the constant factor approximation algorithm for vertex cover. We showed that there is no such algorithm for click and independent set. We had a constant factor approximation algorithm for shortest tour. We did not touch upon 3SAT, unfortunately, here. Regarding a PTAS, we know there's none available for vertex cover. We also know there's none available for click and independent set unless P equals NP. We mentioned briefly that there might be some available for special cases of shortest tour, but not in the general case, also not for 3SAT. Then we had the Monte Carlo algorithm for 3SAT. We did not go much into Las Vegas algorithms here, but what we then also did, we mentioned that all of these problems here are usually much better solvable in practice than the worst case analysis and their NP completeness suggests. Now compare this table of knowledge with what the 4 computer scientists and you knew before taking this course. And I think you now know a lot about challenging problems, but also about the techniques that you can use to solve them. So it's of course not all good news, because in general these problems are hard. But using this arsenal of techniques here, you'll usually be able to do something about them in practice, as others have before you. And I think that can really make you stand out among other computer scientists, because not many computer scientists understand the concept of NP completeness alone. But even those that do, once they encounter an NP-complete problem, they will tend to just give up or use some random algorithm, not a randomized one, a random one. Whereas you now know about these techniques here and can use them to try and tackle those problems.